This is Algebra 1, test number 4, spring test from week 14 study guide. First one says solve the equation using square roots. Remember, you work your order of operations backwards. First thing you want to do to get x by itself is you want to undo plus 6 by subtracting it. If you subtract it on one side, you need to do it to the other side. You're left with 7x squared on the left equals 7 on the right. Undo the next step, undo multiplication of 7 times x squared by dividing by 7. You do it to the left, do the same to the right. You're left with something that says x squared. You're left with something that says x squared is equal to 7 divided by 7 is 1. Then in order to get x by itself, you undo the square by taking the square root of it. Take the square root of the left, again, do the same to the right, and x equals 1. 1 times itself is 1. Remember, the negative value is also possible for that one. Undo the same thing with this next one. You want to get it to say x equals all by itself. It says plus 20. So you undo plus 20 by subtracting it. If you do it to the left side, do it to the right side. 4 minus 20 is going to be negative 16. So you have something that says x squared equals negative 16. You do the same thing, though. You undo squaring something by taking the square root of it. When you do it to the left, you do it to the right. Now it says x squared equals the square root of negative 16. There are no numbers, even though you think of the number 4 times itself gives you 16. There are no numbers that give you a negative value. So x is equal to no real numbers, or none. No real numbers, or no real solutions. Number 3 was solving these by factoring. Now you have something on the left is equal to 0. Unlike number 1 and number 2, where they had x squareds for those, these now are in standard form. They have x squared, then they have x to the first power, or in this first case, z, but a variable. So what you need to do is you need to take the trinomial and you need to separate it into 2 binomials. When you separate it, z times z for the first one, then you need to look at your factors of c. Now your factors of c of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. One of those pairs of numbers has to get you to b's value, which is 2. When you put 1 and 24 together, you get 23 or 25. 2 and 12 give you 10 or 14. 3 and 8 give you 5 or 11. 4 and 6 is the only pair that gives you 2 or 10. So we're going to have to use 4 and 6. The same rules apply, though. This sign in front of C, since it's negative, tells you they're either the same or different. Negative means they're different. And since you have different signs, this sign right here in front of B tells you the sign of the larger value. 6 is larger than 4, so it's plus, and 4 is minus. So now you have 2 binomials. One of them says z minus 4. The other one says z plus 6. I'm just going to clean it up a second. Z minus 4 times z plus 6. You take those that say equals 0 and you make each one of them into its own separate problem. Z minus 4 equals 0. Z plus 6 equals 0. Then you undo those one step for each problem. Add 4 to both sides. Z's value is 4. And subtract 6 on both sides. Z's value is negative 6. So those are your 2 answers for number 3. On this next one, it's the same format, but there's an a value. We have not gone over how to factor out something with an a value other than 1. So this one kind of snuck on there, but you would do it the same way. So let's just omit this one. That was a mistake. This next one, c squared minus 10c is equal to 0. In this case, they both have a c in common. So c times c minus 10 is equal to 0. All we did was factored out the c in both terms. You're going to treat it the same way as we did for number 3. It almost acts like this. So this C, this one, is equal to 0, or this C minus 10 is equal to 0. Undo the minus 10 by adding it to both sides, and C is 10, or C is 0. Number 6 just tells you to simplify the difference. Remember, you write your answers in standard form, which means the largest exponent goes first. 2 is the largest exponent. 3w squared minus 4w squared. Those are the like terms. So you subtract 3 minus 4, and you get negative w squared. Then you go to the next biggest degree, or the next biggest exponent, which is 1. Negative 8w, again, minus 3w. Negative 8 minus 3 is going to be negative 11w. Then you go to the next degree, which is the one that has no variable at all. Negative 5, again, minus negative 3. Remember, minus a negative 3 like this means plus a positive. So negative 5 plus 3 is going to be negative 2. And here's your polynomial when you subtract them. Number 7 tells you to simplify the product. You distribute not just the 3, but the x to the 7th power as well. Do the coefficients first. 3 times 4 gives you 12. 3 times 6 gives you a positive 18. So then do the variables. X to the 7th times x to the 3rd. Remember, anytime you multiply the same bases, like x to the 7th times x to the 3rd, you add the exponents. 7 plus 3 gives us x to the 10th. The other one, when you try to multiply x to the 7th times y to the 5th, they're not the same bases. So you simply have x to the 7th and y to the 5th. You don't add 7 and 5 together to get 12 in that case. And you can't put 12 and 18 together right here because they don't have the same exponents. Do the same thing with number 8. Distribute 3 times 4 is 12. 3 times negative 6 is negative 18. Do the same thing with the variables. 8 to the 6 times 8 to the 7 is 7 plus 6, which is a to the 13th. And 8 to the 7th times b to the 6th. Again, different variables, so you have a to the 7th, b to the 6th. Very similar problems here. Number 9 tells you to write it in standard form. Remember, that means the biggest exponent followed by the next biggest, and so on and so forth. The largest one we see is g to the 3rd power right here. So it's the whole term that goes with it, the negative that goes with it, the 5, the g to the 3rd. The next biggest one would be g to the 2nd if it's available. We have g to the 2nd right here. It's positive 7 g to the 2nd. The next biggest one would be g to the 1st power. It's available right there. It's positive, even though there's no sign in front of it. We know that that's positive, so you put plus 9 g to the 1st power, followed by the thing that has no degree, the thing that has no variable, negative 1. This is standard form. Simplify the sum, unlike the one we did a minute ago where we were subtracting, now we're just adding. The largest degree goes first in standard form, 3u to the 3rd plus 4u to the 3rd. You add 3 and 4 to get 7u to the 3rd. Notice we're not adding the u to the 3rds. Go to the next biggest degree, u to the 2nd, 6u to the 2nd. There is no u to the 2nd in a second polynomial, so it's just simply positive 6u to the 2nd. The next one is u to the 1st. There's only one. There isn't one in the first one. And it's a negative value, so you simply write it in as negative 2u. And then finally, you go to the ones that have no degree, 3 plus 7 to get a positive 10. And here you are when it's simplified. Number 11 tells you to find a solution to the system of equations. Remember, you can use the elimination method or the substitution method, or you can graph them and estimate where it goes and plug that value in. That's usually the least desirable way to do it. This one's set up nice and neat to use the elimination method because we have 1 for each one of these coefficients. Remember, we need opposite values. So we can either make our y's -5 and +5, or we can make our x's -2 and +2. We already have a -2 for our 1x, so let's just multiply this top equation by 2. 2 times 1x gives us 2x. That's what we wanted to where we could eliminate it. But you can't do it just to one term. You got to do it times everything. 2 times 1y is plus 2y. 2 times 8 is 16. These are the two that we're going to combine, this one and this one. -2x and +2x gives us 0x. We eliminated it. That's what we wanted to do. 5y and 2y gives us 7y, and 5 and 16 gives us 21. Now we have 7y is equal to 21. Undo 7 times y by dividing both sides by 7. Y's value where these two equations intersect is, 3. Now once you have one value, plug it back in or sub it back in to one of the first equations. Remember, usually the first equations are the easier ones. The very first one seems the simplest to me. X plus y equals 8, where y's value is now our new value, x plus 3 equals 8. So get x by itself by subtracting 3 on both sides, and x's value is equal to 5. You have an x and a y value. Remember, a solution to a system is the point where they both cross, x comma y, or 5 comma 3. This is your solution to your system. Number 12 says the sum of two numbers is 81. Sum of two unknown numbers, x plus y, I said 81, is 82, excuse me. Their difference, remember difference means minus. X minus y equals 36. Write a system, then solve it. This one is set up nice and neat for elimination since we have 1 as our coefficient for all of those and negative for that y. When we put these two together, 1x and 1x gives us 2x. 1y and negative y eliminates that y. 82 and 36 gives us 118. So 2x is equal to 118. Divide by 2 to get x by itself. X is equal to 59. So you have x's value at 59. Plug that 59 back into one of the other ones. Just use the first one if they look the same. 59 plus y equals 82. Undo positive 59 by subtracting it on both sides. 12 minus 9 is 3. 7 minus 5 is 2. Y's value is 23. So one of your numbers is 59, x comma y. The other one is 23. And there's your system, your solution to your system.